All right, so hello everyone. I'm Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon to try and figure out the future for smarter buildings. So great to have you with us today. So in case you're wondering who we are, our profiles are listed on mondaylive.org. Um, and also just to point out, the views expressed here are personal, not of any company or organization. Keep that in mind. And let's use the Zoom chat to make this as interactive as we can. Um, that makes it always more interesting. So this being the 16th of June, we sort of got a late start to June's theme, which is OEM disruption. So we're going to be talking about that sort of broad aspect of how a lot of the technology that we're seeing and the changes in behavior and other things are sort of putting pressure on OEMs in this industry. So looking forward to that conversation. And today we're going to have a conversation on OEM disruption, but we're going to focus mainly on the mechanical equipment, the mechanical equipment that's becoming more and more smart as the day rolls on. But before we get into that, going to hand it over to Ken Sinclair for an update from Automated Buildings. Ken.
Thanks, Anto. Let's go up to the top left-hand corner there. The top item there is that was put in chat last week, and if you click on it, it takes you to what these folks are doing, which I think is great. They're democratizing AI. Whoops, there we go. With personal AI, it's a good. Just listen to the YouTube they've got there. It's good information. The one below is our contributing editor, Suha, is basically she's doing some training with LinkedIn, and the word physical AI came up. And if you actually take your AI agent and ask them what the heck is physical AI, I think physical AI sounds a lot like us. It sounds like this is basically the edge. I think the key word, as Anto and I were just talking before, is actuation, that we actually do something. A lot of the AI that we're doing, we're asking questions and getting answers back, and then re-feeding the answers back in, and we're basically talking to ourselves. But when we get physical, we actually move something, we actually save energy, we actually yeah. So I think that's our that's our play on AI, is we have to make ourselves different. And why we're different is we are physical. We actually do something with AI. So I think that's an important thing as an industry. Okay, the one below that is the summary of last week's meeting, or Zoom, I guess is a better word. Future hinges on open collaboration, edge intelligence, and nurturing the next gen talent. I think that's good too. As we touch Linux, we're getting into a whole bunch of new communities, and this is great because we're getting a whole bunch of new people, and they're coming with their understanding of open systems, open cloud. The only thing they don't know is they don't understand well our physical side, and I think that's our job, is to welcome them in and teach them the physical side. Now, I attempted to put together a little, myself and Jim and I put together this distributing opportunities for the industry equipment suppliers, OEM, and basically just asked Gemini what the opportunities were. I fed it in a bunch of information to kind of set the scene, and it gave us a great response. And I think that's kind of useful for today's meeting. The one below that, inaction to innovation. I think that's probably a good definition of the radical change we've seen in the last little while. Is basically Kimon's summary of what went on in at Realcomm or IBCom. And so he did a really great job of doing that. Thank you very much, Kimo. I do appreciate when you go to these seminars and you capture so much of it on video and append your opinions on what's going on. That's a very good summary. I'm very proud of you as a contributing editor. You're a good example for all our other contributing editors. The other thing over as we start moving the other side of the page there, if you're not following myself, it's probably worthwhile because there's just a lot of stuff flying by, and we're getting more followers. I think we're up in the 22,600 or something like that. We've gained 200 or 300 followers in the last few months, and we're starting to just the myriad of stuff. I quite often just grab stuff as I'm working through social media that I think might be interesting. I just say of interest to our supporters. So there's a lot of stuff flying by. I'm kind of trying to pull together as much of this as I can as it goes by me. And this is one of them, Stephen talking about just a bunch of startups trying to deal with all of this stuff, and there's just other ways of doing it. I think trying to for people relating to us what they're doing with AI, I think this is very, very useful. When we click on somebody's blog or post and we see how they're using it. And I think this is an example there that you might want to take a check out. One below that is Navigate is a platform, a seminar that's coming up, put on by Jim Hill and this group there, Navigating Smart Building, the IoT platforms. I think that's this Wednesday, if I remember right. And then the one below that is we posted this last week, and I was impressed with the amount of action it got on LinkedIn, just to do it yourself, the approach. And again, that fits into what I was talking about before, is I think we need to share how we're using AI because everybody's got a different twist on it. And when you get inside somebody else's head, you see, oh, wow, that's interesting. And AI is how we're going to play on the physical. Take a look at back to the start to what Suha is doing there. In her video, in a matter of a minute or two, she whips through all of the variants of AI and kind of categorizes them, which is kind of a good summary as well, I found anyway. I think that's about it. Back to you, Anto.
Great. Thank you, Ken, as always. The link board, as always, is there in case you want any of the links. Any other thoughts or news anybody want to share before we move on? All right. Hearing nothing, let us move on. So we're talking about OEM disruption, and really the focus of today is about the future of smart connected equipment. I just put that up there just to start this conversation going. And we do have a guest today, and guest is Kenny Seaton. Hey, Kenny. I'm just gonna let you introduce yourself. I know that you have a lot of interactions with Keith, who doesn't seem to be here. He's probably lost somewhere or in the car somewhere. But please introduce yourself. Tell us what you do with Keith, and also I think you won an award or something a couple of weeks back. So tell us about that.
Just a little one. Hi, my name is Kenny Seaton. I'm the Director of Central Plant Operations, hence my background photo and strategic energy projects at California University, Dominguez Hills. I've been working with Keith for the last 5 years. I think we met right when he got into Basile, and been kind of the test bed guinea pig site for. I'm the guy that'll push any button and see what happens till it faults out. So had a lot of fun there. But before that, I was also my middle name was Test Pilot or something like that, right? So every new pilot project that came out, I'm like, well, let's try it. Let's see if it works. And so I've reduced my greenhouse gas since 2018 by 71%. And I've reduced the gas usage at the central plant by 96%. Just this last year by moving to large scale heat pumps. I was fortunate enough to earn a Digi Award at the IBCon RealCon conference for most intelligent higher education. And without, hopefully nobody here is from Stanford, but I'm pretty excited that I beat Stanford. So, in a nutshell.
Okay, thanks. Great that you could be with us. Kenny, do you know if Keith is going to join us?
I was told he wasn't leaving me on my own, but you know, who knows? He said he was going to call in because he's got an appointment that's an hour away through traffic. So, Anto locked up.
Yeah, Anto's frozen.
There he goes.
Are you back? Are you back or are you frozen?
Well, I was just going to say that I don't have that much to contribute because I don't know much about boilers or equipment. So
Point me in the right direction. I don't know. I got invited to come talk or to be part of this, but I wasn't. There was no pre-con for me, so I overheard you guys talking a little bit the other day by your conversation about embedding AI into equipment and stuff. Is that the direction this is going?
Well, let me maybe jump in here then. Having a little bit more experience in the background of equipment. I think let's just maybe back up and reset the picture is the equipment is coming alive with with agents being built into it, or some type of artificial intelligence is becoming part of it. And I think there's a couple of movements. You're in, like, I would classify as an independent movement where you're working with Keith and you're modifying significantly your existing equipment. That's kind of one big picture. But the other big picture is that the chiller manufacturers are starting to think about this. And then there's another strain of all of this is that we're starting to see a kind of a change in the industry, which might be even classified as a move away from central systems to compartmental. And we're seeing some projects coming in that way. And of course, all those compartmental units come with, they're a little easier to basically turn into AI agents. So I think the best part to start, Kenny, is if you could tell us how did you modify these existing monsters, and maybe some of the what should we say, jousting that went on with the major chiller people, because that's an interesting thing is some of these chiller people have a real misconception about, they actually believe they still own the chiller in your building. But that's not quite true. We have to take ownership of them because it's more important how they operate in the building than what it was they thought, what they think it's going to do. So maybe just lead us a little bit into that journey.
I think it starts in the beginning though, right? Before the chiller, it starts with the entire campus. And part of that is whenever we install equipment, we have to make sure that equipment can communicate with whatever some front end of some kind, right? So for me, it's always been a JCI campus. And so everything that I've installed, whether that's lighting systems or meters or whatever, they had to talk BACnet. And there are other ways to do it, but that's the path that we chose, right? That was the first hurdle, right? Because you can't, everything, I know, Ken, you just said we're talking about compartmentalized, but at the end of the day, everything affects something else. And so by bringing that together so that it can communicate, AI can really start taking off. But before that, again, things communicate and have to talk together. If we're talking about the chiller, when I have 3 1,000-ton YMC squared York chillers, they were put in 5.5 years ago, and JCI installed them. They were bought from JCI, and JCI does the maintenance on them. So they've got an extended warranty, and if they hiccup wrong, I call them up and say, it's on you to fix. Now, when I started talking about doing AI stuff, the first hurdle was they were installed with a condensing water flow of 2,300 gallons per minute. And that was the design, right? 1,000-ton chiller. So equipment manufacturers install things, engineers design them at design, right? At that worst case moment. And so that means for 5 years, I was running 2,300 GPM through a 1,000-ton chiller, regardless of it running 35 or 40 tons in the middle of the night. And so that was one of the things, right? And I had to call up my chiller tech who works for Johnson Controls and say, hey, what's the minimum water I can run through that? And he actually not argued, but didn't want to give me the answer right away until I convinced him, you know, and finally he sent me over and said, okay, well, here's the minimum and here's the maximum. And I'm like, okay, great. And then, you know, then we started talking about it. Okay, well, how can we match the flow to the tonnage, right? That's the first thing. And then it was a condensing water temperature set point, right? How many people out there run a static 5 degrees, 7 degrees above wet bulb, or 80-degree sump temperature or something like that, right? We ran 5 degrees above wet bulb for 5 years, 6 years. And then we found there was another way. And so I wasn't too worried about warranty or any of that stuff, because in my mind, Facile is a really smart, sophisticated sequence of operation that runs on a more powerful computer than my JCI. Keith will call it a Commodore 64, but right, that computer that's running that logic that says, hey, look, wet bulb plus 5 degrees equals X, and that's what the set point is. There's really no difference right now, except for the data, multiple data sets, probably 5 of them, get brought into Facile. Facile says, hey, look, here's these data set points. I think you should run at this temperature. And we told Facile beforehand, look, I don't ever want you to run below 60. I don't ever want you to try and get above 90. On the flow, I don't ever want to see you go below 1,300 gallons, and I don't ever want to see you go above 2,700 gallons per minute. And so as long as you stay in those ranges, honestly, what's the worst that can happen? The chiller may fault out, or it just runs really inefficient. Well, we were running really inefficient for a really long time, although I didn't know I was until we started implementing and pushing the buttons and, you know, fine tuning things. And so, you know, that wasn't what got me to a 70% greenhouse gas reduction, but that is what got me to a 48% central plant KW efficiency increase. And so if we set the guardrails up, and we can set guardrails in the AI, and we can set guardrails up in the central plant JCI stuff also, right? As long as you set those guardrails up, then why is there anything to be afraid of? And then it's just, let's see what it can do. Can it get better? You know, did it get worse? Did it get better? And because I was the guinea pig and the early adopter, there was things that we learned that, you know, I don't need to go into all those, but we figured it out, right? And when it screwed up, all that happened was we ran inefficient, you know? And I called Keith up, he was up in my conference room. Dude, what's going on? Why are we at, you know, 0.7 all of a sudden, you know? It's like, oh shit, okay. That number's no good, fine tune that. Now, a month ago, our system crashed because I was an early adopter running it on a desktop computer. And that desktop died, and it wasn't in IT's repertoire. Somehow or another, I fell out of the system. And so when it died, there was no going back. It did a whatever fault it was on the hard drive. We basically started over, and Keith said, look, I've got some data, because we had 18 months of 5-minute data of where it should be running at certain conditions. I said, you know what? No, let's just let it learn and see what happens. Because to me, it's just exciting, right? The way we do things typically, JCI, Siemens, whatever, is a very static. It says, look, here's a program that says 5 plus wet bulb equals the temperature you're going to run. Facile doesn't have that. Facile has these 5 points and says, look, I want you to run them wherever you want to, as long as you get the best KW per ton. To me, that's the magic of AI. And that's going to be the magic of AI when we start implementing more and more. Here's my parameters. Here's my guardrails. Stay within those guardrails. And what can you do?
And so, yeah, we found out it took, what, 10 days or so, Ken, 14 days to, you know, somewhere
Yeah.
around there.
Yeah, exactly. It took less than 2 weeks, and even when it started up, it wasn't terrible, and then it got better and better. And the longer it runs, the more data sets it gets. Like I said, it's doing a 5-minute one, and so it's working really well. And then I am so excited about, what is AI going to do next, right? How is it going to make my optimum start stop better, right? Because the problem with the way we used to run things is that the way we used to run things was very static, right? It was this time we do this, and this temperature we do this. But we can only look at a couple of those numbers, right? AI can look at a lot of different variables, because when we really start getting deeper into it, like what's the optimum chilled water set point, right? Discharge temperature. Well, that may affect the optimum condensing water temperature, right? Because as we change the flow through the chiller and we change this and we change that, all of those things really push on the other piece. And so we might compartmentalize certain aspects of what's going on, but at the same time, when those change, they will have an effect on the other things. And if we were running old school static linear equations, then it wouldn't matter, because we wouldn't see that, right? And now the AI is able to see those granular differences. And that's the exciting part for me.
Have you looked at all at digital twin, or are you running any of the, like, you're running all this real time? Is there any twin scenarios where you're looking at, if we did this, we might have been able to do better, or?
I haven't done any of that. One of the reasons is I'm focused. That's right. So right now we're focused on Facile. And it's not needed. Although my vision of the whole big picture is, it's not a digital twin because it's live data. So why do I need a twin? But my vision is all of that data is brought in, and we have one data set point to be looking at, right? So,
model or whatever. Yeah.
Right. And so all that data is in that same place. And so AI is connected to all that. And so now it can say, hey, look, you know what? You can't get any more efficient than this, because all of a sudden this sensor is out of calibration, or this widget died. But here's where you can buy that widget, and here's how long it's probably going to take you, and here's the location of it. And so I believe the next step is not so much digital twin as it is just that full model where everything is brought together, an asset management package that is live data from your plant that's also talking back to your plant, is where I see us in the future.
So that's really, really interesting, Kenny, and I appreciate your thoughts and feedback on that, because I've been in a similar space, right? Everyone went down the kind of digital twin thoughts several years ago, right? But when you think about it for a moment, the whole purpose of the digital twin model was that you could bring all that remote data into a digital image or digital representation, where a person, a human, can go twiddle knobs and say, well, what if this, what if that, what if this, right? And that was the whole premise for digital twins at the time. I think your observation is kind of where I am at too. I think AI has passed the need for digital twins. I don't, in fact, I don't want the person in the loop. Let's just let the machine do it directly, right? In which case I don't really need a representation there for the person to see it per se.
The problem with digital twins in my mind, or in the vision that I had of what digital twin used to be, and people still use digital twins in a much broader sense now, right? But before, it was exactly what you said. Well, how is that any different than the engineers that sat down and decided what my sequence of operation should be? We just found out with the condensing water temperature set point that there's no model that would have told us that was better, because we all have our biases.
Yes.
The digital twin model is programmed based on what we know, right? And so who knew that by changing this number, we would increase the efficiency of this object or widget over here? We can now see that. And so how can you model that unless you can actually do it, right? And I get mad at engineers all the time, because they'll say, oh, you should do this. And I'm like, look, what works on your slide rule calculator perfect model computer is not the real world. There's just too many other influences there's thermal mass and there's flow and there's the sun and there's the humidity. All these things are not in your model, or at least the ones that I've seen.
Yeah, and I agree with you too. I think that was part of the challenge that the original digital twins had, is that they basically re-represented stuff that the engineers already were sitting in front of, and then that begged the question, well, what was the purpose? And some of the feedback I used to get in those days was, well, we don't trust our engineers because they have biases, literally, like you say, right? Because they have their own biases. So I want to take it, quote unquote, out of their hands and give it to someone else to be looking at the digital twin and doing the clever stuff. And again, I come back to, well, we've done that, except we've just given it straight to the AI engine, right, instead of another person at the end of the day. So I'm in I think digital twins are dead, but Kimon might have a counter.
Oh, okay, but okay, I agree with that. The other thing I'd like to bring up is way back when, I always bring back the way back when, I grew up working with Hartman and his dynamic control theories. And Tom and I, we got excited when we first had DDC because we were able to see things that we'd never seen before. And one of the ones was the actual position of every chilled water valve in the building instantaneously. And what we would do is we actually did reset of the chilled water temperature from at least one of the cooling valves had to be wide open. And if it wasn't wide open, then you were running the chilled water too cold. So that kind of thinking, I think we were on the edge of it there. And I come from computer simulation. I was the assistant energy analyst for the province of Alberta before I started actually SEA at SAS, our consulting company. So anyway, we had a lot of experience in how computers look at the work, and we wrote some algorithms, and we were getting the kinds of numbers you're getting. And the other thing that is really obvious that I think we all have to understand is the exponential power input with volume. So as soon as you can vary the volume, all of the heating that was going into the chilled water loop from your chilled water pumps is so greatly reduced. And basically running the low volumes just gives you those incredible savings because it's an exponential saving. So some of those basic theories, but I too am excited about what we can add to AI. And I think valve position would be exactly one of those things that we need to look at. And in our old clunky systems, like probably trying to do that if it's a Metasys or something, that's probably a painful operation. But if that data is set free, and we can instantaneously see every chilled water valve position on campus. And I worked a lot in a large central chilled water plant where we had chillers down on the river and basically a mile of chilled water distribution. And by varying volumes and controlling temperatures, we were able to actually bring on new buildings on a campus by doing it. So I understand very, very much the power that you're dealing with there and how effective that can be. Yeah, so I think that was a good circle with the twin. I think I agree with Anno on that, is the twin's usefulness. So what we're really doing, in my mind, is enhancing some of the stuff in the dynamic control theory that was laid out in the early 80s with Tom Hartman. Tom was a visionary in my mind. He's one of my
Yeah,
mentors.
definitely. I mean, I look at it, I call it affectionately a Siamese twin instead of, I mean, it's a model that's bolted directly to the piece of equipment.
Yeah.
Yeah.
And the AI figures it out in real time based on the telemetry. So our AI is not looking, a year ahead of time and a year back and all that. It's just trying to calculate for the next 5 seconds. That's what it does in real time. It's inference compute. It's not training compute.
Okay, one of the things that, and again, I think it's worthwhile to bring up some of the stuff that Tom had, is we very much looked at the dynamics of buildings. The fact that you can actually almost run almost any, and you know this, Kenny, you can run any chilled water for 3 or 4 hours and nothing will happen. It doesn't get better or worse. It's basically the anticipation and looking at the thermal mass, how that's all shifting, and having a lot of simulation experience, you kind of understand the mass transfers that are going on. And I think AI, I think you're just, my shot from the hip is you guys are just on the cusp of what you can do with this. I'm believing that you can add more data to it and come up with better situations. And there's not so much the digital twin, but a feed forward algorithms that are coming out of simulation.
Yeah,
And
that's it.
actually, the other thing that we've done very successfully back in the old days is we actually buried sensors in the mass in major buildings. We had a particular building that was one building that was 3 blocks long and had a waterfall on top of it, and it was all made out of concrete, so it was very massive. And that sucker took about 6, 7, 8 hours to change. So if you made a mistake, if it got away on you, you had to chase it for that long. And then if you got it too cold, then you had the same problem. So you had to have feed forward control. So I think in some of those algorithms we're going to have to put, but exciting stuff. And obviously the results you're getting are cardinal. Yeah.
I think, I mean, you hit so many things on the head there, Ken. Like, I don't run the central plant at nighttime anymore. I use the thermal storage energy in the pipe distribution loop. I don't have TES. And I learned that as long as I move water through the loop, there's enough energy still stored in that water to keep the server rooms cool. And if one gets warm, then the central plant starts up, everything's good. And when it does start up, it starts up at 500 tons instead of running all night at 50 tons. And so I have Belimo smart energy valves in every air handler now, right? And that's my next thing is to, okay, exactly what you said. We should be controlling temperature based on those. The same way we do air handlers and static pressure resets, we should be doing that with the water, right? Now, in Metasys, that's a lot of points that I have to look at. But in the AI, you write one simple equation that says, hey, I want you to look at this, this, and this, go out there and grab all those points. And it's done. That's the other place where AI is going to really move the needle, is that a lot of campuses don't have really sophisticated facilities control specialists running their stuff. If they want to make a little tiny change, they got to go reach out to whoever they're handcuffed to and pay them $175 or whatever that is an hour. And they're going to charge them for 2 guys for 8 hours to write this code. And then we got to come out and test it. And we got to do all this stuff. And it's like, well, in 10 minutes, right? It's like, hey, here's the points I want you to look at, and here's the object, and here's the guardrails. And so as the masses increase, we're going to be able to save more greenhouse gas in more places easier, right? Because it's not going to be these, every single one is a one-off right now.
Okay, I'd love to add another couple of ideas to that. Is the project we had 1 million gallons of storage of chilled water, and that gave us a whole other kind of a situation. What we did is we ran our chillers off peak. So none of our chillers, we basically started our chillers up, charged our 1 million gallon tank, and then we ran off chilled water off our tank. So there's another opportunity for you to actually add storage somewhere. What you just told me is I have a tremendous storage in my chilled water lines.
Yes.
Because the system has, maybe 100,000 gallons or something. But you can see the advantage of creating that. Now, the other thing is in a demand sensitive situation like you are in California, basically interaction with the grid is now something that you and Keith can just make happen.
Yeah, and that goes back to takes 3 hours to see a difference, right? So in a demand response event, if I was running 45-degree water, all I have to do is set the set point to 51 degrees and cruise for the next 2 hours.
Yeah, we did a lot of that. But we would do that to push through our storage, and yeah.
A lot of people are
your job is complicated. Like I think that's the other thing is it's like flick the switch and turn the chiller on, and it's like, it's not that simple.
Right.
There's a lot of stuff, a lot of moving pieces.
But going, so a lot of people, this is where like Keith's analogy about the factory of the future is the man and the dog, right? The dog, the man is there to feed the dog, and the dog is there to keep the man from touching the controls, right?
Mhm.
Because whether that's touch them or not touch them, right? We are so conditioned that, oh, you must have 44-degree water. What temperature you run? 44. What air temperature you run? 55. What flow do you run? You know, blah, blah, blah. And it's like, we don't know what we don't know, right? And people are so afraid of getting outside those ranges. How people ask me, Ken, how is it that you only run 120, 110 degree hot water in the summertime and maybe up to 155 in the wintertime? How did you find out you could run that low? I said, well, I just kept turning it down until people complained.
Mhm.
Right. And so how do we, it's the same thing. Well, we could do the same thing with AI, right? It could start turning things down until it stalls zones that were at an uncomfortable level, or until people complain. And then that's input that we give and say, hey, look, we can't do outside of this. That's where it's gonna change everything, right? Is because we have more data points we can bring into it. It can make those variances that we're afraid to, or, you know, we're so conditioned that this is how we run. No, Ken, what do you mean warmer water is running your chiller more efficient? Your chiller runs more efficient the colder the water. And I'm like, yes, it does. But my plant runs more efficient with warmer water. And aren't we looking at the price to make a gallon of chilled water? Not the price of the chiller to make a gallon of chilled water, but the whole system, you know?
But I think also this grid management is coming into everybody's camp.
Yes.
An article I've just written, they're talking in California, you've got this, they're calling it the belly of the photovoltaics, and the fact that you have a situation on the cooler days where you have a lot of sunshine, you're actually generating so much solar that you actually have to start shutting down your wind. Obviously you've killed your carbon, or your gas fired. But anyway, that's rippling back, and that's rippling into the rate. And if you have a situation that you can push your peak even a few hours, like if you could actually alter your set point for a few hours and still maintain your cooling, then there's probably huge savings and interaction with the utility. You know, that all starts to make sense. And that's, like I say, ours was simple because we just ran the chillers off peak. And but they would actually phone, or in the old days they would phone you and ask you to knock off some capacity, but that would all happen just in a automatic demand response. Are you on automatic demand response?
No, I have a large scale battery that took me out of that program, but it's being done through somebody else for that thing. But the problem with that demand response also, as far as the running things in off peak is the middle of the day now.
Mhm.
Right? And so now, do you have enough capacity to charge up your tank and keep your campus going so that you don't run the chillers in the middle of the night, depending on what your load and stuff is, right? And so
Mhm.
that's going to be a huge change. I mean, we've already seen it in California. You know, for me at residential, power is cheaper from 8 in the morning until 5 in the afternoon. That's the cheapest time for electricity.
Wow, that's interesting.
Okay, because of all the sun and solar and wind and all that stuff, right? So there's an excess. So
So you're on time of day billing.
yeah,
Okay.
yeah. Well, no.
No.
Yeah, no, yes, I am. Sorry. Yeah, I have 3 different at residential, we're time of day billing. Yes.
Okay.
We don't get charged for peak yet, although there are some states that have peak charges also. So
But I think the big thing of the important of this discussion is that this is all getting very complicated,
yes,
but it's not complicated for AI.
no,
And
no,
it's
give
not
it the set points and the parameters and let it do what it wants to do.
yeah,
Well,
it's not
And I
not
think
complicated for Keith either. I mean, understands all of these parameters that are going in there. So it's just a matter of him getting those measured variables into your to your AI algorithms.
can you also talk to, are you doing anything with occupancy based changes?
Yeah, so I started doing occupancy based several years ago. I was an early adopter of the Enlighted lighting technology that now just went
Yeah.
away. But besides for that, before that, I do not heat or cool spaces with no people. I do not do a setback. I just shut the VAV, right? Now, I do that in 90% of the spaces. 10%, somebody that's a director with a, southwest facing window, and, in the time it takes him to get down the hall to use the restroom and come back, his office went from 72 to 78.
Sure.
That one has a setback, right? But, and that's another big thing that, we have to stop designing for the 10%. We need to design for the 90 and customize for the 10, right? Or put that into the AI and say, hey, look, now I can customize every single space if I want. And so, everywhere that we went with occupancy-based control, we basically cut the energy in half on the buildings.
Wow.
And so, and if they were pneumatic, and we went pneumatic to DDC with occupancy-based, it was a better than 50% energy savings. If it already had DDC, then it was closer to 40%, savings. But yeah, occupancy is huge, right? We have to figure out how do we stop sending energy and lighting and heating and cooling to places that don't have people. That's the if we just concentrated on that, you could forget everything else.
Yeah. Yeah. Well, especially in today's workload, work home from home, work from here,
Yes.
process.
Yes.
It's changed. I think that dynamic has changed occupancy, HVAC control significantly in the last few years. That was a struggle before,
Yeah.
it was marginal.
The other problem that's in there is the tail that is wagging the dog. I mean, you've got that 1 or 2 rooms that you cannot cool. You can start your whole plant up and you can't cool those rooms because you physically don't have enough. And
Yes.
actually getting those solved and coming up with an alternate cooling strategy for those areas, so they are not wagging your system. There's big savings in that.
Or worst case scenarios, you just take them out of the equation. Like
Yeah.
they're not allowed to, they don't they don't speed up my fan or slow down my fan or turn on that air handler, It's like, I'm sorry, you take any brand new building and I would bet lunch that you're gonna have 1 to 2 of those zones that were built perfect, brand new day one, and they're at 100% of the time. And you end up running at 1.5 or whatever the maximum static pressure was that the design engineer set you up for. And you look at it and you just go, what were you thinking? Those are the rogue zones. Get rid of them.
So I would love, first of all the work is amazing, Kenny, and it's great to hear these anecdotal stories. I would love to hear about how this has impacted the number of headcount you have and the truck rolls that come to site, because owners will be like, oh great, you saved us energy costs, but a lot of the time on the commercial side, those costs are just passed on to the tenant. But where the real savings are is in headcount and manpower and maintenance costs and things like that. So could you talk to that side of things a little bit?
Yeah, I mean, it's a little different for me because my headcount is on the campus, right? And so for me, usually you ask the opposite question that I usually get, right? I'm not going to lose any people because of the AI, right? my people are actually more productive. They see these changes. So now I'm creating energy champions so that I'm not the only one, right? They're fixing it. It opens your eyes up to the things that were problem areas, right? As you start tuning things up and you see all the waste, then, you stay busy fixing those other things. But the energy savings, the fact that I can tell you that we added 300,000 square feet and we use the same amount of electricity or less today than I did 5 years ago, up until I put the heat pumps in, I'll be honest, speaks for, there's the savings, right? Now, the problem with that is that in that same time, I went from 12 cents a kilowatt hour to 24 cents a kilowatt hour.
Wow.
Right. And so that $1 to $2 million, that the reason I got the nickname Kenergy was from the budget director we were up $1.5 million 2 years in a row. And it was like, wow, right? And then the next year hit and everything changed, the war in Ukraine, and rates changed in our direct access account. And overnight, and it lined up perfect with fiscal year, because that's how the contract was, we went from 12 cents to 24 cents, which means, yes, I'm using the same amount of electricity, but the budget for electricity was $1 million more that year. And so, and it hasn't slowed down. That was a few years ago. We were at 27 cents now. I think we'll be at 29, you know. And so I can do everything I can to, you know, but you can't stop the ocean, you know. So it's you know, my head's in a different place, David, than your question, I think, right? I believe that it still works and that you're still going to have people having to fix those things. But if you can continue to stave off the energy cost, right? Because at the end of the day, that's what we care about. How much is this going to cost us, right? Well, what's the cost of doing nothing? You could just keep inflating the bill, or you could do something and now maybe you don't have to have those increased costs. But I don't think you're going to get rid of, you might eliminate some of the truck rolls because you won't have those silly ones, right? But you're going to have the ones that you got to fix now, right? And so your resources are going to be better spent because you're going to see those important things that need to be done.
So in a way, in the same way that you're optimizing everything, you're optimizing your manpower, perhaps, as well, is a good way of looking at.
Yes, like, so now instead of my manpower answering hot and cold calls all day long, every day, now they're cleaning up the IT closets that we did our own IT work, and IT's pissed off at us. And now I have a guy that's going in and labeling and straightening our cables and making sure we know where our stuff is. Now we're able to spend more time. I got a guy that's studying up on sequences, and now the heat pumps, we're doing better things with the heat pumps. Now, as AI grows and we give it over to that, then, you know, that's going to change also. But, you know, the AI is not changing sensors. It's not, you know, this DP switch failed and this, you know, our AI completely wiped out one day, and my mechanic was blaming it 100% on the AI because the fans on the cooling tower are going up and down and up and down. And we shut off the AI and it didn't get much better. And we finally found out that our humidity sensor had cobwebs built up inside it. It had been on the side of the building for 5 years. And all of a sudden it just overnight started changing 5 degrees like that. Well, I don't care if you're running AI or if you're running 5 degrees above set point. If the set point changes that much, then things change, right? And so,
yeah,
cleaned it up, fixed it, turned it back on, everything's back again, you know? And so I don't see us getting rid of manpower, right? But I do see our buildings running much more optimum. I see us not having to have 3 chillers in the summer, because 3 chillers was what we needed to cool every single space from 6 in the morning until 10 o'clock at night. And now we're only cooling the spaces that have people, right?
Yeah.
We're not doing it from 6 until 10. We're doing it only when the people are there. So now all of a sudden we got by last summer with 2 chillers instead of 3. And so
that's
Yeah.
amazing. Yeah. And I see Steve Fay and Tracy both have their hands up. So I'd love to see what Steve's question is first.
Okay. Hi, Kenny. My question regarding the optimization, you've done optimization with Facil as essentially an add-on to the way the controls were normally set up. But from the OEM's perspective, did they offer you a chiller optimization solution
Good question.
that would try to do what the Facil AI is doing?
So no, they did offer me their connected chiller platform, JCI.
Okay.
And that
Right.
was, and the reason I signed, and I did it, I paid for it for 3 years,
Mhm.
was so that, because I told them, look, I want my chillers to be the most efficient out there. That's what I'm about. I'm all about energy efficiency. So if I have this and the data goes right back to your engineers, you know, high level engineers, and they're looking at the data and they find something, tell me how I should run this to make it better.
Sure.
And I did that, and they never came back with anything. Basically, all it was it's a tool for them because they're the ones that have to cover the warranty, in my opinion. because at the end of the day, you know, they would show me things that say, hey, this one's not as efficient as this one, but they couldn't figure, they don't know why. They didn't have any suggestions on how we should do things differently. Until there was something that was really bad. And then it's like, well, it's under warranty. Why don't you figure it out?
Right.
So no, they did have their open blue stuff that they wanted to do. I demoed that for a while. It didn't do anything. They never came back with, again, I put it in. I said, hey, come to me if you can find something that works better. Show it to me. That didn't happen yet.
Yeah.
And then we ended
So-
up Facile.
So you gave them plenty of opportunity. They just weren't in a position for whatever reasons
Yeah.
to take advantage of it.
wasn't there yet.
Yeah.
Okay. Okay,
So
thank you.
yeah, and I
So
didn't discourage, but I mean they're working on it.
interestingly, my question is similar. Build on that a little bit. Given your experience and, you know, you're using an aftermarket, let's call it an aftermarket product that utilizes all the existing OEM hardware and equipment and in the control systems and so forth. But put your future thinking hat on for a minute and talk to me how you think or what you see shaking out here 5 years, 10 years from now in terms of technology like this disrupting the OEM side of it. But and there's two, to me, in your case, there's two sides of it, the equipment manufacturer and the controls manufacturer. What do you see happening in the future with these guys?
I see the controls manufacturers being somebody that can create a solid piece of hardware that can run processes and connect to all of our stuff and run cleanly on our network. I see the third-party AI doing the actual algorithms that tell our stuff what to do, with the exception of the fallback stuff, right? I would never do a third-party stuff on my campus if I didn't have a fallback, right? What if the network goes down? What if this happens, right? You know, how is that stuff going to run standalone? That's where I see it going in the future, because that's going to unlock things, right? A great company can come up with a really nice Jace or whatever you want to call it, right? Bolted on, it can talk IO and IM and all these different things. And we can bring in all our digital and our analog and our stuff. And it all goes to one place and the AI can do something with it. At the same time, we can write some generic code that says, you know, 5 degrees above wet bulb, do this and run your fan, so that if that third party becomes, look, I can use Facile, I can use John Smith, I can use Carrie's, I can use Tracy's, you know, and it's like and I can change that yearly. We can go out for bid. We can look at different things. Now that's not going to happen, because once we find one we like, you know, we're good with it. But that's where the market's going to go, is to those AI companies that are able to create these smarter scenarios. And how quick can they integrate and do things? You know, what does that look like on security? Is it a small footprint? Is it this giant thing? That's where I see the future, truthfully, right? And then just what are those extra widgets? You know, I mean, I'm waiting for the day when, you know, Keith has already done it years ago. I want to be able to take my smartphone and say, Facile, put me in DR mode, right? And it automatically happens. You know, Facile, is Air Handler 1 really running? You know, yes, the static pressure is X and the speed is Y, you know. And those extra widgets are going to change things. But at the same time, it's going to be the ones that we hear about that are calling it digital twin, that are going to be, you know, yes or no, the static pressure is reading 5, you have a problem and it's located here. And, you know, so there's another feature. That's the future. I worry about embedding too much AI into the actual hardware. Like JCI, this chiller, it should be set up to run efficient. But the problem is that it still has to talk to too many other different systems, right? Because let's say that I'm not a completely JCI campus. And then I have to worry about dealing with them to do the updates, because they're the only ones that are going to be able to do some firmware update that may or may not make it run better, right? If I keep the AI outside and I just have the equipment as a really nice, solid piece of hardware that does what it's designed to do, give me the parameters that I can go stay within, and then I want the third party to make those adjustments for me.
A good example, by the way, you can challenge Keith on this, and Keith will probably shoot me, but that challenge you had with the outside air humidity sensor or outside air sensor, right, just going crazy, you're having the challenges. So it turns out AI is actually pretty good at keeping an eye on those type of sensors and saying, yeah, hang on, there's something going on here, as opposed to which BASs tend to struggle with. And then to your point, that's the challenge of it. Well, if Johnson's is doing the chillers, but your outside air and humidity is somewhere else, somebody else, how do you want to be able to intersect all that stuff, and JCI may or may not be the right answer for you in that context.
Right. And I mean, Siemens, Honeywell, whoever's they are, right?
Sure,
You know,
sure,
you know, I don't want to pick on JCI, just we're a JCI campus, but I've had this conversation with other, you know, campuses, and we all have the same, whoever our control company is, you know.
Yeah.
So you don't think manufacturers putting AI in their equipment is a good idea? You'd like the separation of the two.
I would like the separation of the two, because I want it all to run from one brain, right? If I put the AI in the chiller and I put the AI in the pump and the tower and the air handler, then it's everybody's doing their own thing, and I don't really know. And but worse than that, like I said, is that equipment's going to run for 10 to 20 years. How long is that AI going to be updated? What's going to happen with that, right? Can I then override their AI so that I can use a third party, or is it going to lock me into this? You know, we all talk about open operability until it actually, you know, the rubber hits the road, right? And then it's like, oh, well, no, we have to do this, you know? And so just give me a good solid V8 and I'll tune it up the way I want to.
I'm going to steal that one, Kenny.
That's good.
Yeah, I think this has been fantastic. Thank you very much, Kenny. This is really great. Any other last question? I think we have maybe one round, couple of minutes. Rick, you've been very quiet. How do you see this play out in terms of, you know, where you're looking at from what the industry does with all of this?
Yeah, I think everything you described of having the independent layer be where the AI sits, because in a multi-vendor world, you have to be able to accommodate and allow for the mix and match. Plug and play is just plug and play with all one vendor's parts is probably possible, but plug and play with multi-vendor is probably difficult. You threw me when you insulted the Commodore 64 and the slide. After that, I was kind of just half listening, Kenny. No, I thought it was fabulous, because the future, and again, we're representing C4SB, which is part of the Linux Foundation, and talking about how the multi-vendor world with all these lots of different moving parts, especially here in the short term, is going to take it's going to require that kind of approach that you're describing, and a lot of domain expertise. And we're going to bring Ken Sinclair back out of hiding to start to help to tune all the stuff that Kenny can't get to. That's what I'm thinking.
I'll bring Tom back. He's still there. Anyway, the other thing I'd like to point out too is we've focused on a particular university campuses are a breed onto their own. And I grew up in, we created our first DDC system in the University of Alberta back in 1975, and we had that central chilled water system. So I understand Kenny's environment quite well, but there are a lot of other environments that are quite different. And I think what we need to do is maybe next one of these the other weeks, we now then have to focus on compartmental units and all the other variations of how this gets done in office buildings and where we don't have centralization. Central plant is it's fun, but it's a unique animal unto its own.
Yeah. Okay. Let us wrap this let's wrap the show up. Thank you very much
Yeah.
again, Kenny.
Yeah.
Thanks, Keith, for
Thank you very
organizing
much,
that.
Kenny. Good
You're
job.
welcome. Yeah, thank you.
Thanks for inviting me. I like to share.
Uh-huh.
Good.
And we'll get a
Thanks,
video
Ken.
out, and hope everybody has a great week.
Okay.
Yeah.
Okay,
So,
Thanks.
Thank you.
Bye.
thanks. Bye.